One of the most exciting tools over the last several years within the Wi-Fi space has been WLAN Pi, a very creative solution built on top of course, Raspberry Pi technology. And the people that do it put a lot of love and effort into making this thing happen and giving it the capabilities that the industry has asked for. I've been noticing a lot of discussions on social media lately about this thing being updated, enhanced, and really turned into something even better still. Well, the good news is today we have with us Jerry Olla to talk to us about what they're doing with WLAN Pi and what this tool is all about and how you can find its best use in your environment. So let's jump right in and take a look at what Jerry wants to share with us today.
Hey everyone, it's Jerry Olla coming at you here with a big update to the WLAN Pi project. Before we dive into all the new hotness and unpack all the new tools that are included in the WLAN Pi 2.0 update, what the heck is the WLAN Pi project? The WLAN Pi project is a community-driven open source project started in 2016. It's focused around building a portable and versatile tool set for Wi-Fi professionals. It's built on top of Armbian, which is a super lightweight Linux distro. And if you want more information about the project itself, head over to WLANPi.com. I know this is going to come as a huge surprise, I'm sure, to many of you, but I am not the brains behind this project. There are people much smarter than I behind the scenes doing much of the heavy lifting on this project, and I am super thankful for these guys. It's been awesome. Honestly, this is my favorite part about being involved in this project is the community aspect and the people that have stepped up and willing to contribute their time and skills to furthering this project has been awesome. These guys are also hanging out in the Q&A section, so reminder to use that question pane and submit your questions, and we'll try to get those live during the session. You'll also hear from a bunch of these guys and their contributions during the presentation. All these guys have had a huge contribution to this 2.0 update. That is everybody except for that Joel guy. Hey, who put Joel's name on here? I'm just kidding. Joel's been an awesome contributor. I always got to give him a hard time any chance I get. Joel actually did the 3D printed case for the handheld edition of the WLAN Pi, which has been an awesome contribution to the project. He's probably printed about 1,000 of these or so by now. So yeah, thanks Joel for that awesome contribution to the project. All right, so the WLAN Pi 2.0 update, we had some big objectives we needed to accomplish with this update. We needed to completely overhaul the development process, make it more scalable, easier to collaborate. We also needed to greatly improve the usability and just refocus the overall tool set that's included in the WLAN Pi image. So what we ended up with at a high level is something like this. We rebuilt everything from the ground up, revamped the entire tool set that's included in the 2.0 image, also included several usability improvements, and also expanded the hardware support at the same time, being able to support other Wi-Fi adapters, and now being able to easily port the tool set over to other hardware platforms. So the development process, I always like to use coffee analogies in my presentations. If you don't like coffee, my apologies, but this is where my mind goes, right? So we went from a very manual brew process or image creation process that was very labor intensive to something that looks a bit more like this, right? Very robust. We can all be pulling shots at the same time or building on the code at the same time, building images for multiple platforms simultaneously. So this is really where we've taken things. Rather than me try to explain the low-level details of all this, I've asked our resident Linux guru, Daniel, to step in and talk to you guys about that.
Hi everyone, I'm Daniel Finimundi, part of the WLAN Pi team, talking to you from Brazil. And today I'm going to talk about the general development process and how it evolved. So when I first heard of the WLAN Pi, I really wanted to contribute to the project, but all customizations were done manually to an image flashed into a WLAN Pi, which made contributions difficult. We did have GitHub repositories for different features, but it was still a lot of manual work to glue everything together in an image that was ready for deployment. We're using a vanilla Armbian image as the base image for this process. And Armbian actually already provides us a build system that we could leverage to improve our process. So we dove in and we forked their GitHub repository and started to customize our own image. This opened new possibilities for the team, since now we could automate the image generation, installing and configuring all the packages that we wanted. Everything here is scripted, so we can make a change and have an image built and uploaded almost effortlessly. We can also generate this image for multiple boards, basically anything Armbian supports. And this is just a simple configuration change in the build system, and we have basically the same image for this target board. This whole image generation process is good, but no one wants to reflash their SD card every time there is a new image version. That's why we are leveraging Debian packages now. From the kernel to the applications installed, almost everything is a package which can be updated with Debian Zap package management. And even more than that, we also packaged our own applications as well, like the front panel menu system, YPerf, Web UI, hotspot mode, among several others. So there's no more need to flash a new image every time there is a fix or an improvement. You can just apt update, apt upgrade, and you're good to go. For some Python packages, we decided to package them into a virtual environment, which would allow them to be isolated from the rest of the system. So if you eventually mess up the Python installation in your board, those applications are going to still continue working, and you can also update them with a simple pipx upgrade command. We're going to leave the GitHub page at the end of the presentation, so you can check that out. Thank you very much, everyone.
Hi, I'm Colin Balance. On the dev team, I'm probably the one that gripes about Python the most, so I'm going to talk to you a little bit about that. Just to expand a bit on what Daniel spoke about, we're really driving towards upgradable packaging versus system-level images that you'd have to download on their own. While Python system installs were working, we were sort of setting ourselves up for a bit of failure there. We're really locking the end user into our decisions and removing flexibility on their end. So trying to clear that path and make sure that everyone's happy down the future. Right now, we're starting to leverage pipx, as Daniel mentioned, which allows installing and running Python applications in isolated environments. To be honest, it feels a little bit like a Band-Aid, so we're also researching DH-virtualenv to provide isolation sort of in a more system-integrated manner. Think about doing something like an apt install or an apt upgrade just to update profiler rather than having to deal with the pip install. Thanks for the time.
All right, thank you, Daniel and Colin, for that update on the development side. Next up, I want to talk about the changes to the tool set. And as I mentioned before, we've really gone through and revamped the tool set. What I mean by that is, I don't know about you guys, I'm a big fan of less is more. And what we're finding with the 1.9 image is as we continue to update things and add more and more tools to the base image, it was getting a bit bloated, right? There was a lot of tools on there, and it was a bit, challenging to try and keep up with what tools do what, and what are all the different kind of use cases here, and which tool do I use when I want to test network performance. There was just a lot of things that kind of did the same thing, but none of them were really that polished. So what we wanted to do was focus in on the core tool set and create a core tool set that really we could create proper documentation for, and we could really polish up from a usability standpoint. So that's a big focus for 2.0. We're going to continue to work towards that as well and improve that documentation piece now that we have that kind of core tool set. So hopefully you guys appreciate this. You might look at the image on the left and think, there's a lot more tools there than the one on the right, and that is somewhat intentional, right? We're focusing on a core set of tools and making them as user friendly and as usable as possible. So to go through all these different changes that we've got on the toolset side, I've actually asked the developers to step up and actually walk you through those changes and the reasons for that, and do a little demo for you on all these new updates.
Hello, my name is Josh Smelsley, and I'm going to cover some of the updates to the front end and profiler. We wrote the new web UI for the front end using a Python framework called Flask. This lets us run Python code to pull in data, manipulate it, and send it to the front end. So we've pulled in some of the network information scripts that gives us stuff like reachability stats to the internet, public IP information, Ethernet, IP config, and LLDP and CDP neighbors if it's present. The profiler got some big changes under the hood, but for those that don't know what the profiler is, it's a client capabilities analyzer that automates the collection of the association request frame that tells us things that the client claims to support, like 802.11 amendments like K, V, and R, how many spatial streams the client claims to support, and what channels. The big things here are the changes under the hood to support future development, like porting the code from Python 2, which is now deprecated, to Python 3, as well as packaging the script so that we can install it into a virtual environment. Alongside the front end, we've included the Cockpit project, which is essentially a sysadmin tool for the web interface. So this lets us do things like change the host name, start and stop services, change the time zone, all from the web interface. There's also an embedded terminal that we can run inside the web browser. Now for a demo of the profiler, web UI, and Cockpit. First thing we're going to do is go to the IP address of the WLAN Pi. We're going to go to the profiler page. Here's where we'll see the results once we profile a client. We can start the profiler from the front panel, but we're going to do it from Cockpit. We're going to log into Cockpit using the same credentials that we would when we SSH to the device. We do need to check this box so that we can start the profiler service. When this loads, we're going to go to the services page, and we'll see all of the services that run on the WLAN Pi, but we need to find the profiler systemd service. So we're going to go ahead and start it. The client I'm going to profile is a iPhone SE 2020. Should be a 2-spatial stream Wi-Fi 6 802.11ax client. So when the profiler starts, it will broadcast on channel 36 and use a WLAN Pi SSID by default. So I'm going to connect my iPhone to this SSID, and we're going to grab the association request and we're going to analyze it. So we're going to go back over here to the web UI to refresh and see the results. So if we open up the text report, we'll see it in this modal view. We'll see we captured on channel 36. It's a 2-spatial stream device. It supports 802.11ax. If we want to, we could also download the association request in PCAP format to see the information elements. One thing I want to showcase though is what happens when something on the client changes the capabilities. So what we're going to do is we're going to put the iPhone into low power mode by going to settings, battery, and enabling low power mode. So then we're going to go back up to the Wi-Fi settings and connect it back to the WLAN Pi SSID. So I've done that. I'm going to refresh this page and we'll see 2 new files show up for this specific client. So if we click on this, we'll see what changed. So when we put the client, the iPhone, into low power mode, we see that it went from a 2-spatial stream device to a 1-spatial stream device. So we can see those results here. The other place you can see these results and where they're saved at locally, I can show you through the embedded terminal, is to go into this folder. And here are the results. That's it.
Hi everyone, my name is Jerry. I'm part of the WLAN Pi team, and in the next few minutes, I would like to tell you more about the features we are introducing to the front panel menu system. I will start with the buttons. If you haven't used the 2.0 image, I would suggest you go and download it because the buttons are much more responsive than ever before. You will really enjoy the experience of using the device. And we have also introduced a new capability for you to customize the layout of those 3 buttons. So you have the OK, cancel, and move to the next item. The good news is you can now move those features between the buttons. If you have an enterprise-grade switch and you're trying to trace a cable to a particular switch port or even to a particular switch in a switch stack, you can now do it using WLAN Pi. And the WLAN Pi will show you the switch information, the port information. And even if you don't have an enterprise-grade device, you have a solo switch with no CDP, no LLDP whatsoever, we now have a new feature called Port Blinker, which essentially is a feature which will let you identify the switch port on the far end side of the cable. This is WLAN Pi running the latest 2.0 image. And the first feature I would like to show you is the CDP neighbor detection. And from there, you can see that my switch does actually support CDP. I can see the name of the device. I can see that I'm connected to switch port number 2. There's the IP address of the switch, the native VLAN being used by the switch, type of the switch, and even software version. If you have an unmanaged switch and you still want to understand where does the cable go, which particular switch port, you can get this information by using the Port Blinker capability of WLAN Pi. We'll go to Port Blinker and we'll start it. What will happen is the WLAN Pi will cycle its port up and down repeatedly, which means that when you watch the switch port LEDs on the switch, you can now see that port 2 is going up and down, and that is the port we are connected to. We have also added a new server mode. And this is a special mode which enables all the basic network services like DHCP, TFTP, and we also added Wi-Fi console for wired and wireless console port access. And there will be more capabilities coming later on. We're thinking about NTP server and similar capabilities. This mode has a safety check built into it. So after you reboot the WLAN Pi or after you remove power and reconnect the power cable to the Pi, it will automatically switch to the default classic mode. This is by design. We don't want you to connect another DHCP server to your production network or to your customer's production network. So this is there for this particular use case. And when it comes to use cases, how you can use the server mode, this is really exciting. You can now use it for your lab builds. You can use it for proof of concept setups. The way I've used this one is I've used it to upgrade my switch, for example, in the lab. You can upload the FTP image to the Pi, and from there you can upload the image to the switch, reload the switch. There you go, running the latest release. The other use case would be option 43. On Cisco APs, you can use it to point the access point to a cloud-based controller, for example. Or the other special option 43 would be the one we use for Mobility Express or embedded wireless controller conversion to lightweight mode access point. You can easily do this. You switch the Pi to server mode. You tweak the DHCP server configuration. You add the option, and that's it. The access point will get the option. It will reboot, and it will convert to the lightweight mode. So at the moment, we are in the default classic mode. What I want to do is switch the Pi to the server mode. Let me do it right now. The Pi will reboot, and after the reboot, you will see that all services are enabled. There will be a small warning message about the DHCP being enabled. And from that point onwards, you can use it to stage your equipment, to upgrade your switch, to upgrade your AP, or any similar use case. So with that, thanks again for your time, and I will hand it back to the team.
Hello, it's Nigel Bowden here, and in the next few minutes we're going to take a look at YPerf on the WLAN Pi 2.0 image. First question is, why do we need YPerf and what does it do? Well, YPerf allows us to try and answer this question, why is my Wi-Fi so bad? We know that in many instances it's not the Wi-Fi at all. We've got a whole raft of different network segments which could be causing the problem. We've got our local wireless connection, we've got a wired network beyond that, we've got an internet pipe and a whole raft of remote web services we may be trying to access which have got problems themselves. So what we can actually do is deploy our WLAN Pi in YPerf mode and set up a series of network connectivity tests to see where the problem may lay. We can actually set up, we can look at the connection stats for our local wireless connection between the WLAN Pi and the access point. We can do maybe pings to our local gateway to see if the wired sections are working okay. We can maybe set up an iPerf server on the inside of our network and see if the end-to-end network before we hit the internet looks good. We can set up internet speed test to try and understand whether our internet pipe's got a problem, and we can also set up things like HTTP tests for our remote services like Google and Netflix and see whether or not maybe they've got a problem if everything else looks good on our particular network. To actually use YPerf, we just need to set up a couple of configuration files, one to actually allow us to join the test network, another one to actually configure all of our tests that we'd like to perform, and then we actually use the front panel menu system. As you can see here, we select the YPerf mode, actually reboots the box into YPerf probe mode, and then it will perform the tests every 5 minutes that we've configured, and it will gather data over time, and we can configure a whole raft of different service tests like iPerf, speed test, ping, DNS, HTTP and DHCP, and then the results of those tests are actually sent to a Grafana server which we have to configure separately. It doesn't reside on the WLAN Pi itself. We build our own server, our own Grafana server, and then we can use that to display the reports that we'd like to take a look at. So let's have a quick demo. So here is my Grafana server I've got running here, and you can see this is a high-level probe summary report that I've created, and from here we can have a look at things like speed test results, the health of our wireless connection. We can have a look at our DNS results for a few sites that we've, a few target sites we're trying to test. We can look at HTTP response from those same sites. We can look at the HTTP renewals. We can look at the results of any iPerf tests that we're running. We've got TCP, iPerf and UDP running here, and we've got a few ping tests running over here as well, so we can see what the responses are like from various components on the network. We can also take a quick look at the bottom here, and we've got some health information just showing the various tests that have been run and the health of those. On each of these little panels, we've invariably got a little link that we can use to dive down into a sub-report, which actually gives us a lot more information about the individual test that's been run. So in this instance, we can see server response times for Google and Cisco. We can see the page load time. We can have a look at the HTTP status responses here. We can see they're all stacking up with values of 200, which is a good response time. And then we can actually see the individual statistics for each of the tests we're running. So we can see server time here, the page load time, and then in the background the grey graduation there shows us the status code. And 200 is good, 400 and 500 is bad. So yeah, and we've got a link at the top here where we can go back to the summary dashboard, and from here you can see we've got a number of links which go to a whole raft of sub-reports for the other different tests that can be configured. So just very quickly, going back to my presentation, what's new in version 2? Because YPerf was available in version 1, but we've done some upgrades. There was request for support for testing over Ethernet instead of just a wireless connection. So now you can do either Ethernet or wireless connection to test over. We can now, as you've seen, report into Grafana, and we have to use Influx as a back-end database for that. Previously we only supported Splunk, but now we can support both of those. I've improved all of the canned dashboards, which are freely available for you to import once you've built your server. I've got a little bit of remote config support that's we're bringing in now and testing. Lots of improvements in the logging information if we need to debug anything, and also lots of bug fixes and performance improvements. If you want more information about YPerf, I've got a little microsite there at yperf.net. You can have a look at our GitHub site if you'd like to have a look at the code, and also you can always get to all the information you need from the WLAN Pi website at wlanpi.com. Well, have fun with YPerf. I'll see you soon.
All right. Well, hopefully with that, you guys can appreciate some of the work that's being done on the V2 update. Looking forward to hearing your feedback on that. Wanted to leave you with some roadmap stuff of what's to come with the WLAN Pi project. So one of the big changes that you can expect to see is some changes with the hardware. So the Neo 2 single board computer that we've been using for the past several years is actually no longer being manufactured. You can't buy it anymore. So we're looking at expanding the support for other single board computers. We've been testing out several different ones that are looking promising. The one that's probably looking the most promising right now is the Rock Pi E. You may not want to go run out and buy that yet. We're still looking at some different options there. But yeah, that's looking like it could prove to be a nice replacement. One of the advantages is the Rock Pi E supports PoE as well as has a second Ethernet, has USB 3. So there's several nice advantages that the Rock Pi E will provide us over the Neo 2. We're also looking at the documentation. Now that we have the version 2 pretty locked down, we're going to be working on improving the user documentation. You can check out docs.wlanpi.com. And also, if that's an area you'd like to contribute, we could definitely use your help. Last thing, some links here. If you want to get involved, you can find our GitHub page here, as well as our Twitter handle. Thanks for your time. Have a great day.
Well, here we are with the team, and or at least as many of the team as could join us today. And we're going to be talking a little bit about getting your questions answered. But before we jump into the questions, I want to give the 4 that were able to join us today the opportunity to introduce themselves and tell everybody who you are. So, Jerry, we'll start with you, and then we'll just go around and let each person introduce themselves.
Hey, Tom. Yeah, this is Jerry Olla. Yeah, thanks for the opportunity to come on and talk about this awesome project that myself and many others have been involved in and contributed to.
I'll go next. I'm Colin Valance. I'm sort of Python and hardware guy in the team.
Excellent.
Hey, I'm Daniel. I help to build the image system to provide new images as fast as we can.
Awesome.
And I'm Jerry, part of the team, primarily working on the FPMS, a few other features here and there, CDP neighbors, LLDP neighbors, port blinker, server mode, a few other bits.
Excellent. Well, and what everyone can see is this is a complicated project. There are a lot of people involved. So it's not as simple as one person just stepping out of their work for an hour or 2 a week and throwing something together. There's a lot of work involved here and a lot of organization. And those of us in the community really appreciate you doing that. But there's one big question the community has right now. Where do they get it?
Yeah, quite the timing, right, of this presentation, and then the hardware platform we've been using for the past several years kind of being pulled out from under us, which we weren't quite ready for, but good thing was we were already heading in a direction to be able to support other hardware platforms. So the cool thing is that we're in a good spot now from a project standpoint and a software standpoint to be able to pivot and be able to support other hardware platforms, which was the plan. We just weren't quite looking to make that move so quickly. So yes, right now at this time, it is pretty hard to find them. If you scour the internet, you can probably find a few of them out there. But you're going to pay a premium price and stuff for them because the hardware is no longer being manufactured. If you hit up Keith Parsons with his Wireless LAN Pro store, he might be able to scrape up a few that I think he's kind of hoarding himself. So not to throw Keith out there, but if you are in kind of desperate need of one of these for a project or something, ping Keith. He might be able to spare a couple that he's hiding somewhere. But that said, as we mentioned at the end of the presentation, we do have some plans on the hardware side. I've actually got a plethora of single board computers actually pretty much sitting in front of me and around me that we've been testing out and trying to figure out what is the next platform. It looks like as of right now, we're going to be going kind of a hybrid route of taking a single board computer that's already out there and readily available and building our own custom hat for it to give us the same feature parity and some new features that we didn't have with the Neo 2. So that's going to kind of give us the best of both worlds of keeping the price low, giving us all those same features, but also allowing us to add a few additional features and make it a little more purpose-built for this particular project.
Okay, excellent. And of course, you all have done a great job over the last few minutes answering a lot of questions in the Q&A panel within the interface. But any other questions in there that you want to address now in the time that we still have live to talk to the audience?
What do you think, guys? Did you see any questions come up? I know there's been a few new ones that have come in. Any that we want to kind of cherry pick out of there with the time we've got?
I see a couple of Grafana influx things. I think we could just say that since Nigel wasn't able to join us today, maybe we'll circle back on those again at some other time.
Yeah, and feel free to hit us up on Twitter or on the our GitHub page. That's been a good way for communicating either features or issues, things like that. If you want to get involved, also the GitHub page is going to be a good place to do that. And using the issues section, you can submit ideas and obviously feature requests and stuff there as well.
Okay, excellent. Well, what are your plans going forward now then, as far as your case? What are you going to make Joel do next?
Make Joel do next. Yeah, we've been in some pretty close communication with Joel. Obviously, a new hardware platform, new board is going to require a new case. So yeah, we've been working closely with him on that and kind of keeping him in the loop. And I think we're in a good place from the software side now. We needed to get that out of the way before we could really proceed forward with the hardware side. We actually have the WLAN Pi image now running on several different hardware platforms. I've got it actually running on a Rock Pi E board right now. As I mentioned in the presentation, that's probably the most promising one that we're looking at right now. It has some pretty cool features that I think wireless professionals will appreciate, with the possibility of powering it over PoE, as well as having Bluetooth on board. Opens up some new possibilities that we can leverage as well. But yeah, I think that's really going to be the focus now that we've got kind of the software and development process in a good place to move forward with the project. The focus is on the hardware side and also on the documentation side. We know that's been a good feedback, and that's something that we could definitely use some help with. So if that's something that you feel you can contribute, even if you're not a coder or anything like that, just taking screenshots and writing up instructions and documentation on how to leverage some of these tools would be a big help to the project.
Absolutely. So make sure you do that for them. If you're out there watching today and you've got the opportunity to get involved in the project, particularly in some of those ways, because there's only so much time, and getting the documentation done well would be really, really helpful as well. So, hey, everyone, thanks for joining us here with the chat. And we really love this product that you've got going here. And I think it's going to continue to play a very important role in the WLAN space. So keep up the great work, and thanks for joining us today.